All right, well, I'll kind of get things kicked off. I wanted to take a second, introduce myself and a little bit about what ISSA Consulting is all about. A lot of people ask me, what do you do? And I say consulting, and they say, what is that? And I say, I can't give you a good answer because it is wherever the conversation leads oftentimes. And how I generally base things is we like to partner with organizations, and we work with organizations of small sizes, large international organizations, and it also covers all markets. I've worked with manufacturers, and we work with manufacturers on product development and even testing of products as well. And then we work with a lot of contractors and in-house service providers too, both at a frontline level and even at an executive level when it comes to figuring out workloading, task and scheduling. And then also some of the other things like product procurement and potentially, making complete changes in product lines and equipment, material supplies being used in a facility, and we're trying to set everybody up for success, and it takes a lot of different shapes and forms. And it's really been a fun time. I've got to work on some very unique projects. My background, I actually grew up in central Pennsylvania. I'm sorry, I'm Matt Moberg. I should have said that to start with. I think it's on the screen now. I grew up in central Pennsylvania, and I actually started in the facility management field when I was in high school. I worked at a research lab in the maintenance department at Penn State University. So I've got to do a little bit of everything from cleaning and scrubbing toilets all the way through working with the electrical team and carpentry, building complete build outs of new rooms and new buildings as they came up on campus. Went from there. When I graduated college, I went on to work for a building service contractor. We worked on a variety of projects from, the daily cleaning of several malls in our area here in the capital region of New York State, as well as some really fun projects like new builds of athletic buildings for colleges and universities in the area too. So it's been all over the place. I've also worked for equipment manufacturers in the industry. I've been with ISSA for a couple years now, and I also worked with them in the past, and more so on the Cleaning Management Institute side, providing training and educational services for people in the cleaning field. I'll let Dinesh introduce himself so I don't do all the talking here.
Fair enough. Well, thank you, Matt. And I'm Dinesh Wadhwani, CEO and founder of ThinkLite Air. Super happy and excited to be here. ISSA is a fantastic partner for us, and it's a great platform for education. I spend a lot of my time, educating, the world and the audience, the importance of indoor air quality. Quick background on myself and the company. We've been doing this for about 15 years now. At the core of what we do, really, ThinkLite is a technology company. If there's one thing we do well and we get right, is we understand technology really well. We understand how buildings work really well, especially from a facility standpoint. We know how air travels in and out of the building. We know how to automate and how smart buildings work. So if anyone here, is either doing a renovation or building a building or trying to optimize, even without a major gut out, we have tremendous experience in that, both on the hardware side and software side. So given our understanding in buildings, we started off back in 2009 building sensors and people counters and knowing how space is occupied. And it didn't take too long to get into the world of indoor air quality. And we started to track pathogens in the air, especially working with the world of healthcare. And I know it sounds crazy, but we've been doing this, like I can mention, for 15 years. So back in 2014, 2015, our major marketplace was the healthcare industry, because people in that world truly understood HAIs, hospital-acquired infections, the liability and the concerns and the cost that comes with that. But other buildings like offices, schools, who were trying to trace, flu, right? If you think about it, flu is airborne and it exists in the air, it exists forever. And we tried to kind of advise people on that, but no one was ready to listen and to hear. Hence, it was a healthcare solution. And we were so fortunate to work with the world's top epidemiologists and virologists, and everything you're going to see here today, a lot of it we learned from those very early conversations. and COVID comes along and the entire world flips, right? People realize that you don't need to be in a healthcare environment or around sick people in a hospital to get sick. And we were able to extrapolate, all of our learnings, all of our technologies, and all of our experience into the world of infrastructure and everywhere else. So always happy to advise. Air is one of those things that's always so dynamic. So it's kind of like consulting. It's very data driven. It's important to know what's in your air, where it's coming from, what's the cause, and address it accordingly. So that's what we're here to share with you today. And thank you, Matt. Happy to be here.
Oh, absolutely. No, this is really exciting to me. So I'll give my little input here, and then I'll let Dinesh get into his indoor air quality presentation. I'm sure a lot of questions will pop up along the way there as well. So just like you touched on a lot of things, Dinesh, there, and I think one of the most prevalent things that I hear being involved in the cleaning industry a lot more, and not necessarily always talking about indoor air quality, is you had mentioned, the 2013, 2015, 2016 time zone. And being in this industry for a long time, since I was, a teenager, there's a lot of conversations. Are your floors clean? Are they shiny? Is the trash empty? Is there urine splashed on the floor in the bathroom? Are the paper towels wadded up and laying all over the place? Are the mirrors dirty? And those are a lot of the conversations that were being had within a facilities operation. As everybody knows, COVID kind of changed that entire discussion. And when it first started out, I remember I wiped down my groceries. I'm not going to lie. I'm embarrassed to say it now, but I did at one point. And then we keep learning more and more and getting data points and feedback of things going on the ground. And you start realizing there's a much bigger picture here that's happening, right? There's a lot more going on. And it really relates back to indoor air quality. A lot of folks mentioning, hey, we need to open up windows now, get more ventilation, we feel. But we don't want to forget some of the lessons that we learned during those times, because there's a lot more to it, as we're going to get in today, right? And, applying a new vision and looking through a new lens on what a healthy and high quality clean environment means for everybody involved. And that's really what we kind of want to start the discussion today. Dinesh, I'll let you take over and I'll probably interject with some questions. And like I said before, if you're a little late coming in, please feel free at any moment to pop some questions into the chat. We'll open it up fully towards the end for a Q&A. But I know as you hear something, it might spur you to have a question on the spot. So feel free to put it in the chat. I will be monitoring it throughout. And yeah, we're going to keep this very casual, conversational based. So don't hesitate at all.
Yeah, fantastic. Again, if you have any thoughts or questions, don't lose that thought, punch it into the questions, and I'll keep an eye on it too, and we can address them as we go, or if not, definitely at the end. So you mentioned a good point, Matt, about the importance of indoor air quality. And when people think cleaning, right, the norm is the surfaces and hands. Now, not to undermine that, that's also critically important, as we know, but there's three ways people get sick, right? It's from your hands, surfaces, and the air. And what it has been an incredible revelation, which has been true forever, but now people have become center stages, that 80% of the time people get sick, it's airborne. So just think about it for a second, with the wiping of the groceries and sanitizing of your hands. All of that, made a difference, obviously, but you were focusing on the 20% of the time people get sick. And look at the amount of money and resources, organizations have spent, on that 20%. And, the education or the aha moment here is it should be a little bit more equitable where you spend your time, resources, and attention, because that 80% is where you can really move the needle, right? And you can move the needle in really efficient ways too, that are energy saving or very cost efficient and very economical with high ROIs. And so that's the first thing, 80%. The second thing is, when people think about airborne, the first thing that comes to mind is COVID, right? And even if you think about pre-COVID, even the common flu, influenza, every year, 13 million kids in school would get it. They would come home, the parents get it, parents go to work, and people in the office get it, right? All that was airborne, but people tend to forget, right? But if you go into the EPA website today, right? This is a great piece of information that people need to understand is, viruses and pathogens, as important and critical as they are, yet is number 4 on the list, right? That's the crazy part is there's a lot more bigger problems out there that cause, people to feel sick, wellness, well-being, and affects, a larger percentage of people. So number 1 on the list is asthma, right? 1 out of 5 people in the country have asthma. 1 out of 10 have chronic asthma, right? And if you think about it, whenever asthma is aggravated, right, it has to do with the air you're breathing into your lungs, irrespective of what it is. And indoor air quality has a direct impact, on the wellness of people who have asthma. And asthma attacks, asthma reactions, loss of productivity because of asthma is the number 1 reason why people are absent at work, number 1 reason why people are absent at school, and the number 1 reason of lack of productivity in the country. So just think about what that could mean to your organization, right? And there's no seasonality with asthma, right? It happens all year round. The second one is allergies, of course. Also, one in 5 people, have this in the U.S. And whether it's springtime, or flu time, winter time, in the seasons, people react to these stuff, which is directly airborne. The third one kind of surprised me actually was mold. Initially, many people have the perception that if you have, if you live in the South or like in Florida and Texas, that's the only place you can get mold. Out of the thousands of projects we've done, it's quite unbelievable, the kind of facilities that you see molding, right? All weathers, all states, all geographies, and it affects a lot of people really badly. I mean, people who are sensitive can relate. You can enter a building and it's like, I think I smell mold, or you start to, get a reaction. And of course, you have your viruses and pathogens. So for all of these reasons, indoor air quality is so important. And that's why we need to pay attention to it. Frankly, it's something that we should have done a long time ago. COVID was nothing but a wake-up call, or just a good example of what bad air can do to us as a community, as a society. But there's biggest problems out there, right? That's for sure. So that's the second thing I would say. First, 80% of the time we get sick. Second is why we care. And the final one, just to kind of touch on what you said, Matt, was the fact that we all share the same air indoors. And this is a statistic that will surprise many people. And if you don't know this already, I'm sorry to be the one to score you. But here it is that in any building, right? If you look at this, diagram right here, is you may have someone, sitting, right here in his office, isolated from everybody, with a door closed, and not interacting with anyone who may think he's absolutely safe. But here's what's happening. Whatever this person exhales goes into the return duct. So if you follow, my mouse on the red, return, it goes all the way from every single room, all the way. There is some relief. There's some new outdoor air that's brought in. There's some filtration that comes in, and the air gets, recirculated back into the space. The big revolution here is that less than 5% of outside air gets mixed every time. And less than 5% gets relieved, and less than 5% outside air comes in. Essentially, 95% of the air we breathe indoors is recycled air. So imagine you're in an office building or in a school, the restroom, down the aisleway, the cafeteria, a wing or two away, the office is next door, the nurse's office, we are all sharing and breathing the same air. Whatever one person exhales, the other person inhales. And that's the part where that makes us so vulnerable. It's so critical to know what's in the air, what it can aggravate to you, and hence how to go about it. There's no single recipe for everywhere, but how to go about it to mitigate the risk that's associated with sharing the same air in the room. So hope that makes sense, Matt, of how we can complement the role of surface cleaning, to air cleaning.
Yeah, no, and I think you touched on a really interesting subject from a cleaning facility management perspective, that a lot of these things get either pushed into another department when they're talking about indoor air quality, or completely disregarded in general. And it's important. One of the things in the cleaning industry, you're focused on green chemicals, you're focused on sustainability, chemical free, all of that. And one of the side effects or the benefits A positive benefit from that is indoor air quality, right? Because when you start looking at a lot of the caustic chemicals that you're using, right? Floor strippers, high acidic bowl cleaners, even some of the disinfectants at a higher level. They have a lot of very strong VOCs in them. I know some of the monitoring systems that we worked with, they really register those things instantaneously when they're getting put down on the floor. Floor finish is another one. You know, everybody that's ever worked with floor finish knows you have to have really adequate ventilation in order to get the fumes out. How long do they linger? How long do things linger in the air from even a neutral cleaner that you use on a floor on a daily basis? And you talk about allergies. A lot of people have allergies to these, and they may start getting some of the effects of them that aren't necessarily completely related back to, oh, somebody put down way too much floor cleaner, and that's why I'm having headaches the next day or a migraine, whatever it may be.
Yeah, and you mentioned a great point, man, about VOCs. There's two primary pollutants in any space, whether it's at home or in the workspace or in a healthcare environment or in an office, for example, that we want to touch on. And I think for us to even appreciate the risk factor associated with the VOCs, it might be worthwhile to talk about particles first. So I want to share something with you, is that, many people have filters, right? And they say, even in an HVAC system, I do have some filtration in there, right? I can buy some air purifier from a Best Buy or Home Depot, and I feel pretty safe. Well, I think it's working, right? Here's one important point of education that I encourage every one of you to look at. Whether it's a filter for your HVAC system at home or in the workplace, or you're applying an air purifier from any manufacturer, you want to make sure that you have a MERV 19 level of filtration. That's the key. And I'll tell you why in a second, right? For those of you who are not, familiar with the MERV scale, it's simply a rating of 1 to 20. That the higher the number, the more the filter traps, right? And think about a filter as like a net mesh. The higher the rating, the tighter the mesh, which means you're going to filter out more particles of a smaller size. As simple as that. Most buildings have a MERV 8 or MERV 10 filter. And if you just look at the definition for a second, what does it really mean, right? A MERV 10 filter is about 85% of filtration of all particles that are 3 to 10 microns, and about 64% of particles that are 1 to 3 microns, and 20% of 0.3 to 1 micron. As you go up the MERV scale, what many people did during the pandemic was they bought MERV 13s because that was the maximum an HVAC system could handle. Many air purifiers that you see HEPA filters, HEPA simply means MERV 13 and above, right? And as you can see, all HEPA filters are also not made equal, because you could have a MERV 13 or a MERV 18 or a MERV 19, for example. And the key is, with MERV 13s, which is what most people use, right? You see that it's 90% of 1 to 10 microns and 75% of 0.3 to 1 microns. And let's take a pause here for a second. This has been a big cause in the industry for people to feel skeptical or frustrated or misinformed. Right, because if you remember when COVID first hit and it was announced that it was airborne in 2021, there was this flux for people buying anything that had air purification on it. The key is they had these type of filters, MERV 8 to MERV 13, let's say, which you typically call dust busters, right? That's the type of particles you're cleaning. In order for you to be healthcare grade or to go down to biological pathogens, you need to go down to 0.1 micron. And unfortunately, even when you go all the way up to MERV 18, and you're at 99.999, you're still stopping at 0.2, right? So you want to have a 0.1 micron level of cleaning. And the reason why this little size range of 0.1 to 0.3 is so critical is because of just this one reason, is that that's where all pathogens sit. So I'm sure many of you have unfortunately been victim to this, or you've heard a story saying, I bought air purifiers, but it doesn't do anything. Or Omicron came about, in 2022, and more people got sick. And last year we had the worst flu season ever. Just take a step back, just Google what is the size of these particles of these diseases in the air, and what type of filtration am I applying, right? So that's a really important takeaway. And in order to understand even the further risk of VOCs, it's great to understand how, we are able to profile particles. So with sharp laser sensors, in the FLAIR device, we can tell you that it's a viral load of some sort. Of course, we're not able to do culture testing, so we cannot tell you, I don't think anyone in the industry yet can tell you that, hey, this is flu versus tuberculosis versus MRSA. But what it can tell you that it's a viral load of some sort versus wildfire smoke or mold or bacteria, right? It will break it down for you and tell you what that is, right? So now imagine you have a space where you have all these particles in the air. The key takeaway is that the smaller the particle, the more dangerous it is. And I'll explain to you a little bit of a biology of why that's the case. Really fun fact here is in our lungs, right? Our lungs is our God-given filter, so to speak. We only have one, right? And for example, you've heard of when firemen's lungs, when they're always fighting fires and inhaling all kinds of smoke and contaminants, or people who smoke cigarettes. When they get older in life, you do a CT scan, your lungs look black, right? That's because your filters got dirty, right? Similarly, when you inhale all these contaminants in the air, your filter or your lungs is kind of stopping it from entering your bloodstream. However, the smallest hole in your lung has a diameter of 0.3 microns. Isn't that crazy? So any particle that's sub 0.3 microns goes right through your lungs and into your bloodstream. It's for this reason that it's not a coincidence that viruses tend to be in that size range. Because guess what? If it was bigger, your lung could absorb them and protect you. Or worst case, you get a lung infection, you take some antibiotics, and that's it, right? But when you have these viruses in there, it's going right through, there's no treatment or cure for it, and it replicates in your body. So that's why you can meet someone for lunch, let's say, and feel absolutely fine, but only an hour later you feel crappy because it goes right into your bloodstream and replicates. The Mayo Clinic did a really cool study a while ago where they put some guys, subjects in the room, and they were pumping blood out of their arms, and they pumped 0.1 micron synthetic gold dust into the air. And just to see how long does it take for someone inhaling that dust will start to show traces of gold in their blood. And the entire time period was an average of 9 minutes. Can you imagine? By just inhaling, 0.1 micron particles, you start to see traces of that in your blood within 9 minutes. And that's why these tiny particles, so whether it's viruses, whether it's anything contaminant, whether it is, some wildfire smoke particles, when you break them down partially, tend to get really, really small. And that's the harmful stuff that affects your body and your lungs. So that's how these particles work and move in the air. To add to it, right? Imagine if you could see how a 0.1 micron particle looks like. It's really small and light. It's like a feather, right? It's lighter than air. It doesn't have enough momentum to even move around. That's why when COVID came, the CDC people were saying keep 6 foot distance. Because if someone was sick in the corner, whatever viral load you're emitting, it's not enough to even have weight to move itself around the room, right? It's just floating, if you could see. But then now with VOCs, as Matt was saying, here's a very important part of the equation that was left out. VOCs, as the name suggests, are volatile organic compounds. These are just fast-moving gases in the air that can come from any source of chemical or organic source, as the name suggests. So, for example, floor finish, smell of pizza, someone's baking cookies, perfume, as someone said in the chat. All these things are VOCs. And some VOCs can be really bad for you, right? Like the smell of leaves or gasoline and things like that, and can cause reactions. But some VOCs are okay, right? Like whether you're cooking food or coffee or something, no one ever got harmed from inhaling too much coffee, right? But here's the key, right? Irrespective of if the VOC is good or bad, that's not even the debate that we even want to get into when we educate people about air. The key is VOCs move so fast and at very long distances that they create currents in the air, right? So a great analogy is imagine someone's baking cookies next door and you crack open the door for just 1 second and you slam the door shut. The smoke goes everywhere, right? So now you're creating these currents in the air, and guess what's happening to your tiny 0.1 micron particles? They latch onto them and act as their carriers, and they become, their Uber drivers in the air, and they give them a ride. Right. So now, while having tiny particles in the air could be dangerous to you, having high VOCs increases the risk profile. And if you're monitoring these two things, it gives you the full picture. So now no one may be sick in the room, but you put, floor finish, or you're cleaning the surfaces with high VOC agents, and someone comes into the room and they may have, bacteria, pathogens in them. What would have stayed in one section or one corner of the room is now everywhere, right? So something to keep about of the relationship between VOCs and one, yes, so important. And of course, when it comes to cleaning detergents, some VOCs could be dangerous for you, but even before you get to the danger of the VOC itself, just the fact that it's a carrier of pathogens in the air is one more reason, to fully understand why, tracking and monitoring and solving for not just particles, but solving for VOCs is so critical.
Dinesh, a couple of good questions here. If you
Yeah.
want to slide back to the illustration there of the room and the HVAC system, I think
Sure.
there's two great questions. I think they correlate with each other. Number one from Rula, isn't most the air that we're breathing in when we're in a facility air that's filtered? And what is done as far as, I've heard this, recalibrating or rebalancing your HVAC system so you can bring in more outdoor air. Is that something that's being done? And do you have like a ratio that you think is better?
Yeah, no, that's a fantastic question. And I think it also touches very well on ventilation. So let's talk about ventilation for a second, right? Is when people say, let me increase my ventilation, what does it really mean, right? It means they want to bring in more outside air. While bringing in more outside air is always, seems like a great thing because now you're diluting the air more, right? Is that each time you bring in outside air, you have to condition the air. So it's a direct correlation with how more expensive the energy bills become. So let's pretend now it's 30 degrees outside here in Boston. My thermostat is set to 70 degrees. With every little percent of more outdoor air I bring in, you're going to reheat the air, right? So now to balance your energy efficiency and your cost, what's happening is the way all these ASHRAE codes have been designed historically is that what's the minimum amount of outdoor air I can bring in to just dilute my indoor air with carbon dioxide. I don't want to feel suffocated, right? All these control systems are based on CO2 and thermal comfort, temperature and dilution for CO2. So now if my CO2 levels are okay and the air in my room is already warmed up, let's keep recycling, right? So that's firstly the trade-off. And most buildings, have less than 5%. Now, if you're in a clean room or laboratory or a surgical, environment, then those go up to 100% outside air. And those energy bills are expensive, as you know, right? The second thing is when you recycle the air, whether it's the little 5% air coming outside or the air that's being recycled from inside, they do have filters, right? But here's the thing, they have more 8, 10, or 13 filters. So you're taking care of some of the dust or maybe some pollen from outside, things like that. But your VOCs, your tiny pathogens that are sub 0.3, your HVAC system is not doing that stuff, right? That's why, when people stay indoors, sometimes we've all gotten sick and we're like, I didn't meet anyone. I was just hanging out indoors somewhere. I was wearing my mask and I was far away from people, but it's in the air. And that's what people don't realize is you can avoid things that you touch, right? You can keep sanitizing, but you can't control the air you breathe.
That's great. I know, again, back to the HVAC system, and this is a good question as well, which is once you get up to that MERV scale at that high level where you're doing that sort of filtration, does that force your HVAC system to work harder in order to do so?
Yes, that's exactly right. So if you think about it, right, what differentiates a MERV 19 filter from a MERV 13 filter is basically a tighter mesh. It's not that much more expensive if you think about it, right? A little bit more, but not that much more. The reason why you cannot go to a MERV 19 is because your HVAC, infrastructure is not designed for that. You're going to create so much pressure, you're going to suffocate the system, right? You don't have enough of a fan speed to blow air through such a tight mesh. You don't have enough, of a diameter in your ducts. You don't have enough ducts. So now you put it in there and now you will create such a pressure, it would probably explode. So the pushing the envelope, the highest you could go is a MERV 13 to a typical MERV 8 or MERV 10 design system, which is all the commercial buildings we live in, right, and work out of. And by doing that, we actually did a study for a school system where we compared the electricity bills pre-COVID and when they moved to Moberg 13 filters post-COVID, it was a 15% total increase in energy bills, right? Because now they were just pushing more air into the system, right? It takes more energy, not to even count the wear and tear on the system. They were replacing filters more often. They were changing parts in the HVAC more often, and just a big, big liability. And here's the part that kills me the most. If you spend all this money and resources, but you are truly solving a problem, that's one thing. But even with the Moberg 13, they weren't, right? They were just capturing more dust, which is fine, but not what they intended it for it to be, right?
Absolutely. And I think that goes back to, I see a lot of buildings now. You talk about LEED standard, our GBAC program, Global Biorisk Advisory Council, and its STAR program for facilities. And you get a lot of folks talking about sustainability.
Yes.
And you hear the buzzword, right? Net zero. They want to be net zero. And this is almost counteractive to it, right? If you have to bring in outdoor air and you have to condition it, if you have to run your fans harder to pull them through a filtration system, that adds to the energy usage.
Right.
So they're kind of fighting each other, but at the same time, you have to have that health aspect of your indoor air quality.
That's right. And that's why we strongly believe that the perfect balance is, a large part of our customers, we say, please go back from your Moberg 13 down to your Moberg 8s. Save the energy. And the proper way to keep your air clean, it's not that, because your HVAC system is not your air purification system. It isn't, right? It's to provide ventilation and to give you thermal comfort. So the key is you have in-room purification. It's so much cheaper to cycle air in this room where this person is sitting, so that any pathogens that come out of this room is cleaned right there, right? Or most of it is cleaned right there before it makes its way to the central HVAC and spread everywhere else. So now you're cleaning the air at source. You're not having to deal with these large energy bills and HVAC maintenance bills, and you get the best of both worlds of efficiency and clean air.
Great. And that John Paul asked another question here that I think ties right into that, which is, do you leave the fan on or do you put it on auto?
Yeah.
Does it help either way?
Yeah. So auto, again, is designed by your HVAC engineers, keeping in mind two things: CO2 and temperature, right? That's the controls you see in your thermostat. So the fan goes on and off based on CO2 levels, and if the air temperature should be 70 or 72. It has nothing to do with air quality, right? If you keep it on all the time, here's what you're doing: you are mixing the air more and spreading it more to dilute it. So that obviously helps, right? Because if there's any concentration pocket of viral loads or VOCs and the fan is moving, you're going to just dilute it. You're not necessarily getting rid of it. You're probably just recycling it around the building, but in turn, you're also diluting it. So that's a fair way to go about it, right? And our air quality monitor actually integrates with the HVAC system. So biggest users of our system, for example, is Siemens. When they come in and do an HVAC project, they would integrate a live indoor air quality monitor that's scanning the air in real time to their thermostat. So now if the air quality gets bad and there's stuff in the air, it will send a signal to the HVAC system to say, let's crank up the air exchanges, right? Let's turn on the fan and let's dilute the air some more. In some cases, depending on the sophistication of the HVAC system, it can even say, let's just for the next 30 minutes, because the air quality is just so bad, let's open up this damper even more and bring in some more outside air, especially when outside is beautiful and sunny and 70 degrees. My thermostat has been set to 70 degrees. I won't have to spend too much money, reconditioning the air. So let's go ahead and, use this opportunity to bring in more outside air to clean up the air inside. Right. So it's so valuable to have a smart air monitor that will not just tell you data, but also help you, put into places such automated programs to help you, in an efficient manner.
Great. Now, one of the other questions, and I think this relates, whether you're in a residential setting or a commercial setting. I remember my parents always used to tell me, like my grandmother with the plastic wrapper on a couch still to keep it clean, but a lot of these pieces of furniture come conditioned, right? Whether it's to keep the fire resistance to it, or whether it's to, sometimes there's the stain resistant fabric that has applications applied to it, so it helps, bead water off and eliminate staining of furniture. That does also have an impact on the indoor air quality, no, as some of those VOCs from those chemicals come off. And how long do they typically last? What is the range of that particle? Is it just VOCs? Is that the size of it? And what impact does it have in general?
Yeah, I learned this term recently, Matt. It's called post-construction IAQ management. And when you have new items, new carpets, new coatings, right, new furniture, new cars, right? People say, "Oh, it smells nice. It smells new," right? That's your post-construction offsetting of the gas, right? I thought most people were like me who thought the smell was really cool, but then I realized, getting into this business, ages ago, that many people actually don't like the smell, because they react to it, whether it's allergens or it's carrying more pathogens in the air, and it triggers your asthmas because it's offsetting. And a lot of these furniture things we talk about, well, those coatings have formaldehyde in it, which is at high concentrations can be toxic for you, right? It's the number one cause of, aggravating asthma and long-term, create lung cancer, right? So while these things smell like new, is actually the materials, all the processing that happened in the factory, the petrochemical coatings, they are baking off, right? And we have now mentally trained our mind to say that's the smell of new, but it's the post-construction, offsetting. So if you work in a healthcare setting, in facilities, you probably know this, or in a new construction building, when they build the place and they paint it and polish the floors, they do a purge where they crank up all the air conditioning, open up all the windows, and for days or weeks in a row, they're just blasting air through it, right? To help accelerate, this offsetting of gas. But frankly, it helps, obviously, but it's a slow offset. And the statistic that was published by Well Building was 1 to 2 years, right? You're going to have very slow offset of VOCs coming in, and no matter how clean or good or place your facilities maintain, this risk of pathogen transmission is going to linger. So again, the only way to help mitigate that is not from your HVAC, but having in-room purification devices that truly mitigate VOCs, not just particles, but VOC.
Yeah, that's really exciting. Getting a chance to work on some real estate projects as well, and working with a lot of the home builders and contractors, understanding that they actually condition countertops as well for natural stones,
Everything.
as it sheds that air. And how many buildings now either have terrazzo, polished concrete, even granite quarry tiles, things like that, it has the same impact. And like you said, it's a post-construction clean air management process that needs to be evaluated. A couple other questions popped in here. One about filters. Do filters on vents work? And the other one is, how often do you clean the ducts?
Yeah. So clean. That's a good question. So for filters, right? Here's the thing: the higher you go up on the MERV scale, the quicker it's going to get clogged out, right? So we have seen facilities that used to have MERV 8 filters and replace them every 6 months. Now they buy MERV 13 filters and replace them every 3 months. Not because that's the program, because they have no choice. Next thing you know, there's no pressure in the HVAC and the air is not blowing out because they clog up very quickly, right? So I think there was a lot of efficiency and thought through in the buildings with the MERV 8 design of our country's infrastructure. I think that needs to stay. Switch back to your MERV 8, swap them out 2 times a year, get cheaper filters, they last longer, and know that no matter how high you go up to MERV 13, it's not going to take care of your VOCs and your deadliest pathogens. And instead, use that money or those resources to put in-room purification. That would be, really the core takeaway from this today. And I forget, the second question was the air ducts be clean. Yeah. So in the terms of the air ducts being clean, yes, it absolutely helps. But here's the thing, right? There's air duct cleaning services, which is helpful, and then people put UVC lighting in the ducts, right? Here's the thing: the air travels through your ducts so fast, there's not enough dwell time for the UVC to break down or kill anything. So, truth be told, UVC in the ducts does not, eliminate pathogens or VOCs. It doesn't. What it does do is it keeps the ducts clean. right? So now if you have, any breakdown of mold spores or stuff in the ducts, typically they will start to grow and feed off each other, right? And next thing you know, you got mold growing in your ducts. And now you see it to start coming out of your filters or coming out of your vents, and it can cause issues. By putting UVCs in the ducts or doing duct cleaning, you're keeping the ducts clean so that things don't get stuck there and you don't have debris being clogged up, which will ultimately affect your air quality and maintenance schedule, I will say, but it has nothing to do with, live improvement of air quality. And we've done this several times. Any one of you who have done this before, even is you can have an air quality monitor to analyze the air quality in the space, and you switch on the UVCs in the ducts, and you will not see an immediate or any change in the air quality live. Right, it's not killing anything, in real time, because the air is just flying through the ducts way too fast for it to do anything. If anything, it's concentrated on the surface.
Good, that's good to know, because you do see a lot of that
Yeah,
being discussed now. I'm glad somebody pointed out the smell of candles, and I'd like to hit on that, because one of the things that I see is from a cleaning perspective is a move away from all the strongly scented cleaning chemicals. Right, where you walk into a restaurant and it smells like a lemon or it smells like an orange.
Right.
Those are typical things that you're kind of used to smelling. Even as far as a big reduction in the number of the misters in restrooms used to mask a smell, right? So you get the ones that strictly mask, you get some that are odor sanitizers that can help cling to things. But I think the issue from my perspective now that we know more is that they are in the air, right? Once those things go into the air, they can also get into your lungs. They can take the smell away, but you can also breathe them in. So you see a lot of these changes in the mindset overall.
Yeah, you're actually adding more VOCs to the air. That's what those misters are doing. You're adding more particles in the air and more carriers in the air, right? You're not cleaning anything. You're deodorizing and providing a carrier for your pathogens.
Exactly. And I see the candles mentioned again. Essential oils is another one.
Yeah.
Adding VOCs in there. And my understanding is that some of the cheaper candles are manufactured with chemicals to lower the cost of the candle itself. But it may cause some of those chemicals to burn out when you're burning those candles. Even if you're using just the candle warmer, you are forcing it to be airborne by warming it up.
That's right. So since we are almost out of time, I want to take maybe 3 minutes to talk about what to do with the data when you monitor your air and how to actually resolve it, using a quick case or two. So here's a great example of what you can get when you do continuous monitoring of air. And here's one of my favorite ones. Is now we understand what these things are, 0.1 micron particles, CO2, VOCs. At the end of the day, for any facility manager or anyone who runs a building, here's the unfortunate truth, is that we have no control of what's coming into a building. You have no idea what signals is coming in. You may have a little control of what chemicals people use, but you just don't know, right? What you do have control over is when these contaminants are brought in of any kind, how quickly can you get them out of the air? That's the key, right? And if we optimize and design a solution to start to think that way, that's when we're going to come up with the right answers. So a good example is, this was a project that we did where, when a 0.1 micron of stick people were entered into a room, you see a spike. CO2 went up, there were smells and odors, that are natural around people in there. This is a really high risk environment, right? And the key is, while you have some HVAC going on, you have some filtration going on, like we discussed, you have some dilution of the air going on, some outdoor air coming in. It took an average of about 3 hours, 2 to 3 hours, for all these contaminants to go down to baseline, right? And we learned that in 9 minutes from that Mayo Clinic study, it can go into your body, right? So think about the number of people that can get sick with that one incident. Someone walks in, they eliminate viral load of VOCs and leave. 2 hours later, you could walk in, not even knowing who that person was 2 hours ago, and you were exposed, right? And then you carry it somewhere else, right? It's a snowball effect. But now, if you have the right purification in place, you turn it on, you're constantly cleaning the air. Look at how quickly you can say, well, in the month of February, we made certain changes. We changed our filters, or we put in some in-room purification. And here's how long it took for it to get out of the air. Look at the impact of it now, right? Someone could walk in 20 minutes later and have zero exposure. And you start to trend in the right direction. So now this data can be a really valuable tool to say, well, if I have X amount of resources, where do I spend it? And where do I spend them wisely to move the needle? Turns out that it's in the lobby areas or the locker rooms or the restrooms or wherever it may be, where you're seeing a lot of contaminants come in and you're seeing that they're lingering. Let me spend some money now to go clean the room in that space, right? And now you will directly see impact on the number of people getting sick, number of employees reporting sick, and that's how you move the needle, right? So hopefully that's helpful there. And finally, in terms of the purification, here are two purification devices, that we offer. But again, the key here is you want to have a purification device that does the 0.1 micron. That's so key. And there's VOCs. So we happen to have two products. One is ceiling mounted, recessed, surface mounted, suspended. It's great because in a healthcare environment or in a small office, it's out of the way. You set it and forget it. It's great for restrooms. When you flush, all the pathogens go up in the air and it gets spread everywhere else in the building. You put this above a flush point, it's a fantastic solution. And we have a portable, device that comes with attached wheels that will take care of a bigger area. Think about lobbies, auditoriums. But I want to take a moment to explain, what happens inside to enable it to be a good purification. Now, if there's any other product out there that does the same thing, that's how you can benchmark to say it's an effective purification device, right? The first thing is you have some pre-filters here to take care of the bigger particles. Then you have UVC, 254 nanometer UVC to test germicidal. You break down the viral loads, right? I would say most purifiers does the first two. Right. The part that's missing, that's a lot more rare to find, is within the same chamber, we have a UVA concentrated light with a catalyst that breaks down the VOCs. So many studies show that when you eliminate the VOCs as the carriers of the pathogen, the transmission rate of pathogens is obviously reduced, right? So now you also break down the pathogens. And then finally, you have a MERV-19 filter for it to come out, right? So now, when the air goes through this device, the air that comes out of it, has, a 0.1 micron kill claim on the particles, but on the VOCs too. That's the key. Last thing I'll say is, the number of nines that go behind the device. I used to take this for granted. People cannot really, quantify in their mind, but there's a great, an analogy I like to share with you. Is that, let's say you do find a device that can take care of VOCs, that can take care of 0.1 microns, and you see that, it's 99% or log 2 or 99.9%. A common one is 99.97%, right? We see that a lot of these places. What does it mean, right? So if someone is sick, you are breathing or exhaling thousands of particles per second, right? When you're talking, shedding dead skin, all kinds of stuff. Multiply it by the number of people in the room. Within minutes, right, you could have 1 million particles in the air. Easy. What does that mean? Right? Depending on what virus it is, you need X amount of viruses to carry a disease. So a great example is COVID. It takes an average of 50 COVID particles to carry disease. Because if you and I were to breathe one particle of COVID, that's not enough to harm us, right? Our immune system will take care of that. For flu, it's about 30 particles of flu, to carry the disease. Ebola, for example, is extremely powerful and contagious. It takes 2 particles of Ebola to get sick. Right. So depending on what it is, you can now quantify it. So let's take an average number of 50 particles to get sick, somewhere between flu and COVID, right? Tuberculosis, MRSA, it all falls in that thing. If you have no purification going on in the room, right, before it makes its way to the HVAC and comes back an hour in the room, think about the number of people that can get sick with 1 million particles now, right? You divide it by 50, it's about what, 2,000 people, right? Now you get a purification device that has a 3-log claim. You just went from 1 million particles in the air down to 1,000. That's a big drop. But you divide 1,000 particles by 50 particles per, to carry disease. Still 20 people getting sick, and they spread it. Versus you have a 6-log. 6-log simply means 6 nines. You go from 1 million down to 1, right? No one's getting sick. Well, at least a 4-log. You go from 1 million down to 100. 2 people getting sick, right? And just the common analogy is due to bad ventilation or lack of purification, 1 kid in the classroom gets sick and 20 other kids get sick, right? But if you have the right amount of log reduction in your purification, if 1 kid gets sick, you have maybe 1 kid or maybe 2 kids in the classroom getting sick. And that's impact, right? And then they spread it to less people now. So something to keep in mind when you're also trying to find a good solution is how many logs, is it there? And is it taking care, is it a 6 log on point one? And is it a 6 log on VOC? So hopefully that's helpful. And that will take care of it, irrespective of any chemical you use, what's happening in the building, and you can use, the data to kind of validate that it's truly doing what, I want it to do.
I think that's really important. I was blessed with an opportunity to do a project with Royal Caribbean Cruise Line about a decade ago now, and it was carpet care specific. However, in working with the staff, we talked to them a little bit about some of the restroom procedures that they use, and obviously a cruise ship is a confined area with high traffic. And their statistics said that if you go into a bathroom where somebody had norovirus, obviously that's the big ship viral problem, they estimate you had about an 80 to 85% chance of getting it yourself just by going into that restroom that somebody else had.
In minutes, right? That's wow.
So unless you have anything else, Dinesh, so you could spend all day talking about these things. There's a lot to it. But we'd love to open it up to some more questions.
I see. Yes, I see a question here from Corey Calmer. Sorry if I'm saying it wrongly about the reports. Yes, there is a way. So please reach out to our team, and you can get some really, really cool analytics from our platform. And we'll help you walk you through that and show you how it works. So yeah, do reach out, and we'll be happy to assist.
And yes, anybody asking, yes, these slides will be available. We'll get them out probably within a week or so to everybody involved. The other question here from Dale in the chat was, is there a benefit to using, let's say, a MERV 1 to 4 as a pre-filter and then a higher MERV somewhere in the 5 to 9 range as a primary filter?
Yeah, so you see, as a pre-filter, anything, the way I would look at it is anything below MERV 19 is a good pre-filter, really. You're taking care of the dust. Anything below MERV 19, people refer to them as dust busters, right? So you take care of that stuff as much as you can. Keep in mind, the higher the MERV rating you go, the more frequently you got to swap them out. But if you have good lighting technology inside, many people use, mercury vapor or incandescent. We use LEDs, high concentrate, blast for 5 years, you don't have to change the light cell. When you really blast it with really sharp LEDs, you break down all the particles. Some debris stays inside here, you blast it with VOCs, you blast all the particles that break down, and then you have a MERV 19, right? So you can kind of offset, the balance between how tight you want this pre-filter and how much intense light and dwell time you have in the light chamber. So a good purification would have a good balance. So in our device, which we're really proud of, is one of our goals was to make it very light on maintenance. You could run this thing and replace the filters once every 18 to 24 months, despite giving you MERV 19 quality. Because you have a pre-carbon filter here, I believe that's a pretty low MERV rating, but then you have your UVC and UVA in here, and then the MERV 19.
Great. And question about a washable filter. Are they good? Does washing them even work? We see this. I liken this to the microfiber discussion, which is microfiber is great. You can launder it. However, if one thing in there is not a microfiber and has any cotton in it, it clings up the pores and it depletes the ability of the microfiber to work. There's also discussion that the microfiber, when you launder them, sheds off some microplastics as well and can jam up your equipment, or it goes into the water supply too. So again, there's always a con, it seems like, to the pros, and you just have to be able to navigate them and make the best decision for yourself and your operation. But Dinesh, in your experience, washable filters, do they work? Are they good? What do you think?
So washing your filter definitely extends the lifespan, but it doesn't, relieve you from never having to change them, right? Especially if you have like a pre-filter. That's where you can get rid of some of the dust particles or something and extend the lifespan. But you want to be careful when you get to the MERV 19 filters, because if you're trapping pathogens in there or something like that, sometimes it could be biohazard too, right? So we recommend, after 2 years, it comes with a glove kit. You just take it in a Ziploc bag and throw it away. right? Because you don't know what's inside, what's lingering. To help extend the lifespan, the UVCs are shining on the filters too to keep them clean. Again, it's kind of like washing it. What that does is it extends the lifespan, but sooner or later you would have to change.
Then the next question here, this is a good one. UVA, UVC, and UVB.
Or
It's the ideal one for indoor air quality.
yeah, so that's a loaded question, right? So how much time do we have? But I'll try to answer it as quickly as possible. And Nathan, if you want to chat more, feel free to please reach out. We can share my contact information. But see, UVA is the radiation we get from the sun. So have you heard of the old wives' tale that if your shoes are smelly or you painted your walls, when the sun comes out or leave it in the sun, the smells will go away. UVA is not intense enough to be germicidal, doesn't break down viruses, because if it did, you all burn and get skin cancer, right, in minutes. So what we get from the sun is UVA, which breaks down the VOCs. That's why the UVA chamber in here is critical for the VOCs and the carriers of these pathogens. UVC is the more extreme end that will break down the DNA of viruses, bacteria, and mold. UVB is kind of like in the middle. If you do not hit the UVC spectrum, is not intense enough. UVB, just so you know, is what causes skin cancer over a long period of time. Some days you realize that you go to the beach and the sun is extra harsh because you had some UVB rays able to, it was not too cloudy, and you got some UVB rays on your body for an hour, right? So UVB can be intense, can be harmful to the skin, but it's not germicidal, right? Growing up in the dentist, right? You go to the dentist, they put a tool in your mouth to clean, and then they put the same light under a purple UVC light, and it's clean to use for the next patient, right? Because it's germicidal. So that's why we use UVA for VOCs and UVC for germicidal, and UVB, not so useful. At least in this purpose. So hopefully that's helpful.
Perfect. Anybody else with other questions? Are there any other things, Dinesh, that you think are important for people to kind of try to wrap their heads around in regards to indoor air quality? I
think the main one is, I think it'd be great to talk about the ISSA offer is, a 30-minute free consulting where, Matt and his team would get to assess your building. And including in that, at no cost to the end user of the building, is you get a free flare 30-day trial. And the reporting is pretty amazing. Put it in there, costs you nothing, as many as you want, and we'll do a 30-day assessment of all the risk factors or particulates in the air, VOCs, what time of day it comes, how long it takes to settle down to baseline, kind of what you saw today. And from there, it will give you a nice starting point that if you want to do something, here's where to start from. And here's how to effectively, with a high ROI, really move the needle on cleanliness in the space. So we recommend every one of you to please take advantage of this offer. I think it's pretty awesome.
Yeah, fantastic. And for those wondering of what this flare looks like, this is my iPhone, and here's the size of the device right here. So very, as you can see, similar in size. It's very small unit. These are extremely easy to set up as well, and the feedback and the data that it collects for you instantaneously when you set it up is really quite amazing.
So yeah, check it out. There's always wonderful stories. Like we've had people who said, I think we have mold, but they didn't. It was just dust in your filter. We've had people who had like carbon monoxide coming in from the nearby highway, which is silent killer. We were able to catch that and clean it for them. We had people who were using all kinds of cleaners that were bad. So a combination of ISSA recommendation to improve your cleaning solutions, but at the same time, monitoring your air so that they stay low. I mean, all kinds of stuff that comes out from this. So it's a worthwhile exercise.
Absolutely. Well, thank you very much for the time. This has been great and really, it's really been quite enlightening. Hopefully we were able to answer all the questions here that folks had. And if you have any more, we'll get our contact information out to you afterwards here, and you can follow up for sure.
Absolutely. Yeah. Feel free. Matt, your information, anything you need, please reach out to Matt. Between Matt's team, my team, we'll be able to answer any question for you regarding air quality.
Fantastic. Well, thank you again.
Wonderful. Stay well, everyone. Take care.
All right.